Good morning, everyone. Thank you for joining our webinar today, going over our Rothoblaas Smartbook for screws. My name is Chris Chikiji, and I'm the marketing account for North America here, covering our US and Canadian subsidiaries. I just want to remind you, if you have any questions throughout the webinar today, please, on a computer on the top bar, you should see a button for the Q&A. You can type your questions into there, or if you're on a phone, in the bottom right-hand corner, you should see three dots. That'll open up the same menu, and you can navigate over to the Q&A. Without further ado, I'm going to pass on over the presentation to our presenter for today, Alexander Alvarez.
Got it. Thank you, Chris. Hello, everybody. My name is Alex. I'm one of the U.S. tech consultant here at our headquarters at Allentown, Pennsylvania. And today we're going to be talking about the Smartbook timber screws and going over what it is and what it talks about. So let's get right to it. So, uh, so the Smartbook is like, as its name says, is a book where it has a lot of um, research, theories about screws, about wood, about fire, anything related to wood. But also, we also have a section dedicated to the practical side of of timber construction, because you can do a lot of research, but on site, anything can happen. So we want to make sure that we provide the both side of the stories and try to appeal to not just one side, the theory side, but also appeal to the practical side as well. Um, so so first, let's talk about the theory and about just about you choosing the right screw and how it's determined. So in order to determine the right screw, or like determine what connector, or what application to use, you need to understand a couple of things outside of your control, such as the atmospheric corrosivity class, service class, and wood corrosivity classes. Some of them you have some control, others you do not. So for example, let's start with the service class. Service classes, uh, and it's just a way to determine like how dry or wet the wood is going to be. So you do have some control over this, So for example, what's considered service class one is considered inside. So this is like the wood is protected on all four corners, and it would stay dry no matter what, unless something happened in the inside. Same thing to service class two. It's considered is where the wood is kind of covered, but it's still exposed a little bit to the outside, so it's external but covered. So it will still stay dry, and it might get a little wet here and there, but it's still considered dry. But then you have service class three and four. In these two classes, they're considered wet here for the US. So what I mean by that is because service class three is where it is externally exposed. So the wood is outside and it's not protected. So it will be able to expose to the element. And so, if it rains, it's gonna get wet. But also, when it gets dry, it's gonna dry up easily. Um, but then service class four is where the wood is completely submerged in water, or it's somewhat submerged in water. So this is something like decks, where you have to like post on the water. You have the decks not on water, but if there's a tide that goes up, then that whole deck will be submerged. So for the US, we don't have this. We only have dry and wet service. So in this case, service class one and two are considered dry. They're internal. They might be a little exposed a little bit to the outside, but it's covered, so that's considered dry. Any anytime if externally exposed um, or submerged in water, it's considered wet service. So it's kind of simplified for the US, but just something to keep in mind. If you always want to be in dry service, because if you ever seen wood that is wet, um, it and a lot of things can happen to it, from getting very soggy, it gets weak, or once it dries up, the wood isn't the same as it was before. The shape might change, might become it might become smaller. So we want to work on the dry side, so service class 1 or 2. Also, another thing to consider is also the humidity as well and the moisture content of the wood. So here for the US, and this goes kind of almost everywhere, we want to stay right below the threshold, below 16%, at equal or less than 60%. So, um, and as I mentioned before, when wood is wet, a lot of property changes. It might be compromised. Maybe it's not as damaged as you want it to be, but either way, wet is a danger. So water and wood does not go together. So you want to make sure that it stays below 16%. Um, and so we include two things, annual average and maximum. Annual average is like an average, like like this is what we determine, like we want it to be at. Maximum is where like there comes to a point where the would change completely. Um, so what we want to make sure is stay around this range right here, below 16% to be on the safer side. Some wood acts differently, especially here in the US. COT, we say 16%. For other type of wood, I think sawn lumber and glulam beams, we want it to be somewhere around this range, less than 20%. Might be too much. I think 18% uh is the is the number, but this is on the you would find on the national design on the national design specification codes or NDS. But just keep in mind, like no matter what, keep the wood dry, not too dry because then you will lose some moisture content. You might shrink it more, but just keep it at a certain amount where it's considered dry surface. So that's one thing to consider when choosing the right connectors, the right screws. Um, but other things you also have to consider is also the how far the environment of it as well. So it kind of is kind of similar to service class, but in this case, this is talking about everywhere. Um, so for example, like as with your corrosivity class, it's not very, we don't use this here in the US, but it's also something important to note because it's also helps you determine like, okay, how far away am I from the ocean? Um, is this something I need to consider when choosing the right screw? So to better simplify this, we can say that corrosivity class 1 and 2, this is by the similar to service class 1 and 2. That's very similar. Because you can see here, they're further away from the coastal area, they're away from like places where there's water like lakes, rivers, and so this will be considered dry. So if you're around this area, like you're in a city or like in the suburbs where it doesn't it's not close to like a water source, then you should be fine. Uh, you want to experience a lot of condensation. However, as you get a bit closer to like water sources, doesn't have to be natural water source. It can be artificial, like something from like a factories, maybe a sauna, or in places where like it produces a lot of steam, a lot of moisture. Then you'll be pushing it towards areas where you have to, okay, maybe I need to make sure the screws can handle such a good a small amount of condensation or even a big amount of condensation, such as C5. Corrosivity class 5 is considered where like it's okay, it's always gonna be wet, it's always gonna be raining, or it's like very close to a water source, like for example, like right here by the beach. So yeah. Um, Even corrosivity class 4, this is considered like an areas where okay, it's like it's kind of close to the coastal area, but maybe like you're in a pool area, like for example right here, where they have some wooden beams on the roofs, but there's a pool right under it. So it's not close to a coast area, but it's close to a water source. So this is something you have to keep in mind to make sure that you're choosing the right screw based on the environment and also if it's going to be wet or it's going to be dry. So that's second thing. And lastly, one thing you also have to consider is the wood corrosivity class as well. So for this, you have to make sure that the wood you're choosing is the right wood for your screws, for your connectors. So I like to say the wood is alive because each wood is different from each other and they still are active in a way. So for example, like some wood can be too acidic, some wood can be too base or less acidic. So you have to even if you cut it down, that's the acidity that still carries on and carries on within the wood. So you can find more information about this from the wood suppliers. They can tell you like, oh, what type of wood it is and how acidic the wood can be. But that's something to keep in mind because um, not only do you need to determine the pH level, the pH value of the wood, but you also have to see if it has any treatment on it. So some wood comes like natural, like there's no treatment on it, there's no coating of it, coating on it. However, you do get sometimes some wood that are treated. They're like they have a coating of some sort. So for example, some may have like like I think a copper as a coating on it, and with that, that actually provides more protection from wood from water. But the downside of it is that now it's becoming too acidic. Now it's more can becomes an issue for the screws you're choosing because maybe this might have this can speed up the corrosion rate, or this can actually remove the coating of the screws or your connectors. So just wanted to keep in mind as well, you have to consider the pH level, the wood species. You also have to consider the treatment of the wood, if it has a coating or not. And also you have to consider the moisture content as well. So this is putting everything together. So you have to make sure that the wood you're choosing, it's it's not too dry, it's not too wet, or not super wet, like in right here where you have above 20%. So you have to make sure you're choosing the right amount of the right the right environment, the right wood species, and also the right amount of wetness, the wood it is. Sometimes wood comes in um and at this rate, 10, between 10 and 16%, because um, as I said before, wood is alive. Even though you might cut it down, it still carries on a lot of things, and one of those is the water it collected. So sometimes some wood can carry some water within inside. So it's not a bad thing, but obviously you have to be careful, like it doesn't carry too much water in it as well. And so lastly, to wrap everything together, put it all together, you also make sure the service class of the wood. So meaning it, how is it going to be in dry service or wet service? So that's the way to determine your type of screws you need. You need to consider all these three factors. And once you consider those three factors, um, you have to determine like whether or not like, okay, how will it be affected? How will my screw be affected? So on the previous page right here, this gives you just an understanding of the different type of wood spaces there are. And also, that we just try to give you guys an understanding like which wood is considered less acidic and which wood is considered more acidic on the next page. And it also tells you like why this is also important because as I said before, the the, the wood, even if it's cut down, it carries a lot of things. And one of those also those other things it carries is tannin. So tannins is a chemical substance. It acts like a defense mechanism for the wood. Um, so whenever like something penetrates it, it releases tannin, and it can actually what it's meant to, it's supposed to protect the wood, but can also damage the screw as well. So if you can see on this picture right here, you can see what happened to one of the screws that have been inserted into the wood. You can see that for the top layer, there's no corrosion. It was external, but then as you go more and more in, you start seeing the coating starts to change, where you start seeing more corrosion happening. Um, and so this depends, not always depends on the pH level of the wood species. Sometimes it's not like a perfect correlation. Sometimes It depends on the wood species itself. So here you can see um, how different pH level gives you a different amount of tannin content. So as I said before, it's not always a perfect correlation because we were able to um, some exception are, for example, like maritime pine and Douglas fir, where they consider kind of towards the acidics, they're considered acidic based on the wood species, but they have a very low tannin content. So a lot of this information you can get this from your from the wood supplier. So usually a lot of people work with Douglas fir here in the US, maybe spruce pine fir depending on the area. But all of this information you can find on our smart book. You can actually just go back to this page and see, okay, what where my wood, how acidic my wood is. You can see here spruce pine fir. It's one of those very common things here in the US and Douglas fir. You can see like how the difference, like you can see like um, it's considered spine fir. It's considered very low acidic versus Douglas fir is considered an aggressive wood, high acidic, but um, the tannin level for Douglas fir is actually on the lower side. So um, you can ask more, get more information from your wood supplier. Not all the wood are the same, but that's something to keep in mind when inserting the screws. No, it doesn't matter what screws you get it from. Once it's inside the wood, you have to be careful and see, okay, would this screw be corroded really fast because of the tannin, or will it be able to handle the acidic level in the tannin on top of that? So, yeah. We also did a lot of testing of our screws on different type of wood species, different type of materials, like different type of screws to see what happens to it. So we tested out four of our screws. We have a electroplated carbon steel screws, the regular one. We have organic coating, this one right here, or we have our C4 Evo coating, which is an extra layer of protection against moisture. And then we have our stainless steel 410 AC. And so as you can see, after 10 months, depending on different type of screws and different type of materials made out of, I was able to handle the presence of the tannins and also presence of the acidic level of of the wood. Um, you can see here that the electroplated, the regular screw, it dealt with a strong corrosion, and you can see that it started to rust. Even you can see the wood being like getting really bad because of the material as well. Um, Organic coating is another layer of protection from moisture content, but also from tannins as well. It's able to handle that as much. Evo coating, you can see that it did dealt a bit of tannin, and you can start seeing a little bit signs of rust. And then stainless steel usually is the one people like to recommend a lot for like moisture content, like for heavy durability, heavy duty kind of stuff. But something to keep in mind, if you want to go for stainless steel, you might think, oh, stainless steel, I'll just use that for all of my woods. Yes or no. Depends on what you're going for. As you can see here, stainless steel, yes, it has a big corrosion resistance. So for example, on the previous picture, we used the lower one. Even at the lower side of the corrosion resistant, um, it was able to handle the tannin. But as you go higher and higher, get different type of stainless steel, build up the resistant corrosion, you actually lose more of the mechanical strength. So the screw becomes weaker. Stainless steel tends to be very ductile, so obviously you will lose a lot more of the strength of it. So it will become more bendable. However, we are improving our carbon steel, our electroplated screws, by adding different type of coating on it, like different type of extra protection of it. So you can see here that the electroplated screw, the galvanized screw, you can see that it has less corrosion resistance. However, the resistance stayed the same. So you can actually extra coating on it. Right now we are working on the C5 Evo coating. You can see here that it has a higher corrosion resistance, but a uh, and still a big mechanical strength as well. So just something to keep in mind. You have to make can think about like what do I need to what can I sacrifice and what can I sacrifice and how can I make this can I should I still use stainless steel like, in this type of structure detail, or do I need to go with something with like a bigger coating on it and just to make sure that the structure stay in place. So um you have to determine the type of screw you're needed in your project. Not only that, you also have to consider the different type of heads as well. The most common one is the Kanetsung screws heads. You can see them almost everywhere. Uh, is the most common one you can see on many projects. Or you can go for a cylindrical head screw where the head becomes smaller and it can actually help you a lot, especially like if you want to keep it hidden, well hidden, and also to avoid maybe crushing the wood. This is very useful for like reinforcing beams where you want to use a very strong screw, but also not too strong where you're crushing the top layer of the wood. So the cylindrical head actually helps with that, keep avoiding crushing of the wood and actually easy to hide because since it's a very small head, you don't need a very wide wood chip or a wood cap. You can just cover it up like a very small one. Um, and then you have the plate head screws. Um, they're very useful for metal to timber connections because you can see here the head can be able to flush with the steel plate. And if from an engineering point of view, the more surface area there is, the more it's able to withstand a lot more um, um, force applied to it. So this is really useful for like metal timber connections. And then you have these type of screws right here, cylindrical, wide head, and I think this is a 60 degrees screw, 60 degrees screw head. So this is actually very useful for hardwood. So obviously, as I said before, every wood is different. Some can also be very soft wood, and some can be very hardwood. So softwood can be considered like maybe somewhere the pine. Pine is always soft. Douglas fir and onward can be like for example oak wood. Those are very hardwood. So you will need a much more aggressive head, something that can able to still penetrate through the wood, and also where the head can stay flush. Sometimes if you don't choose the right screw head, what might end up happening is where the screw might snap, and now you only have the threaded portion of the screw in the wood, and now you either have to replace the wood, which hopefully doesn't happen, or just replace the screw and just start all over, but this time using the right screw. So consider what type of wood it is to handle that type of durability. So and this is just another like summary of like what we talked about, like choose what screw type to use based on the classes. So I said before, carbon steel, you have to make sure that you're choosing the right higher coating, the bigger coating, that, such as the C5 Evo coating. I want if you're closer to the ocean area. Um, you don't have to use just C5 coating close to the ocean area. Maybe it can be a bit further away, but also you have to consider like, okay, like which can galvanized screws, can they handle, can they get the job done? Is that just enough? So consider the type of screw. Also, the same goes for stainless steel as well. Yes, you can go for the HCR, the high corrosive resistance screw. Those are the most aggressive ones that they can handle even being submerged in water. But you have to also consider like, okay, how much load am I dealing with? Is this strong enough to handle the type of load? So maybe you have to double down a bit. Maybe just go for just the regular stainless steel. It's not as strong as the galvanized screws, but it might get the job done. So that's something you have to double check and make sure the resistance is there. And then right here at the bottom, we actually explain to you the what the our EVO coatings are made out of. So you can see here that the C4 EVO coating is just you see here as an extra layer of coating where we provide resistance for the screw right here at the bottom. This the carbon steel. This is the just the regular screw, and then we what we do we dip the screws in an extra layer of coating, and this actually provides more resistance so that when if water were to come in presence, this coating can protect it from water being in contact with the carbon steel, which I'll talk to you about later why that's important, especially with um, when it comes to water presence near or around the screw area. So, yep. So this doesn't just go with the screws only. This also goes with other type of connectors, other plates, other hangers. Um, some of our hangers are made out of different materials. Uh, a lot of them are usually galvanized or hot dip. Um, however, some of our screws are also made of aluminum as well, and also stainless steel as well. Uh, and also depending on the type of environment, you have to determine like, okay, can I just a regular uh, galvanized angle bracket, can that handle being dry, or can it also handle being wet? Most likely it not cannot handle wet surface, but if you extra, but you can also protect it as well. So if there's protection around, then okay, you don't have to worry about chasing a different type of material. You electro galvanized is enough. And the aluminum, you can see here the aluminum can handle being outside, can handle the wet surface. Um, and it's also very easy to produce as well, aluminum connectors. Um, and then stainless steel, you can see here that obviously it can handle being exposed to the outside environment because it's made out of stainless steel, and stainless steel is a very high corrosion resistant. So I mentioned that yeah, you want to avoid water being in contact with steel. And the reason for that it's because it's a little bit of chemistry of it. But usually when you have um water has electrolytes inside. So um this actually affects the steel. It affects the material. Because depending on what's it being in contact with. So for example, you have a stainless steel screw and then you have an electroplated plate. It can be you can use these together. There's no problem with that. The only issue with that is that if water comes in contact with it, and what happens is that once water gets in contact, it actually speeds up the corrosion rate of of the less noble screw. What I mean by that, less noble means less is anodic, meaning um it doesn't have a lot of electrolytes. However, by putting in water into the equation here, you're actually adding more electrolytes, more than what it was, it was supposed to handle. And so then what ends up happening that on this side, on the less noble side, for example, like the zinc plated screws, you start realize the screw starts corroding more and more. So this is what happens right here at the bottom of this page. You can see here that the zinc plated right here starts to corrode a bit more and actually makes the screw be affected by it. So for example, this picture here, we have the zinc plated screw and a stainless steel plate. You can see here that the less noble one, the one where it has enough space for electrolytes to come in, you can see is affected more. However, if you look at the other side, you have the stainless steel screw, which is not affected by corrosion. The surrounding area it is because um, it is less noble, or it's able to handle, is able to take in more electrolytes. Um, it's a little bit of chemistry, but just a note is that usually zinc is very less noble. And as you go up and up or down, in this case down the graph, you can see that stainless steel is considered the nobler side, or the most the metal that's less affected by water. So you can see here that gold and platinum is the most highly resistant to corrosion. So that's why you see them a lot being used on like on space flights because it's very resistant, very strong. So people like to use that. But we're not making spaceships. We're making um, timber constructions, timber projects. So obviously, yeah, we're stuck with using the zinc, aluminum, and stainless steels. So you can see here that um, you have to make sure that if you're gonna apply a zinc screw with a stainless steel, or vice versa, a stainless steel screw on a zinc plated, you have to make sure that you're avoiding water at all costs. And there's many ways of preventing that. One, the most simplest one is like obviously keeping it protected, uh, protected from the outside environment, keep it inside, keep it dry. That's probably the most simplest, hopefully the cheapest option there is, and the most simplest version. However, we also have many options as well. That also is very easy to do. Um, for example, we provide this type of washer with a sealing gasket. This keeps away the stainless steel, not the stainless, zinc plated screw from being in contact with a stainless steel plate. Uh, and you know, in cases maybe water comes into play, like water comes in contact. What you can do is that this actually prevents water from actually going inside. Since this is a sealing gasket, um, what ends up happening is water will end up around it, and like you know, or the water will like dry up, but no water will get inside because it's actually protected. So this is very useful in like areas where like maybe on roofs where you don't want water going through the holes of the screws and into the wood. And it gives you an extra protection. Uh, Another thing is maybe doing a coating of it, a coating of some sort, or like a tape. We have a nail bed, which is a butyl nail point sealing tape. What you can do is apply it on top of the steel plate and then put the zinc plate screw on top. And this actually keeps it away in contact from zinc plated screw with the stainless steel plate. So this is very useful. Maybe you don't want the sealing gasket being shown. You just want something to be like very quick and efficient. This is another option. And then the other option is obviously using the same material. So, for example, this is a Evo plated screw, and then this is a Evo plated steel. So you would use the same material. So if it was like, for example, stainless steel, you would use a stainless steel screw. So that's something to keep in mind. To making sure that you're using the water that's in come in contact with with the screws. Water in general is will be the bad guy here in all the situation on metal to timber or on timber. So it's always important to protect the project site. Either having like a shelter in place where you protect the connection, or you have a water mitigation plan where you make sure that no water is pulling up on the wood or on the steel, because no matter what, water will find a way to go through the smallest gaps. So once that happens, then you're in not a complete danger, but you're in the risk of danger. So you have to make sure that you're considering that in your project, how protected the connections are, and is there something that you can do about it, or how to go about it, dealing with the damages. So, and not only that with the screws, but also water can actually affect the wood material. It can actually shrink. It can actually what ends up happening here is that it can actually make the wood swell. So um, let's see. We can move on to next page. Yes, right here. Okay. So depending on the wood, you have to. Sometimes what ends up happening is that when water gets in contact with the wood, it actually expands it expands the size of the beam or of the column. So in this case, for example, let's look at this one right here. This is a glulam beam. You can see here that it came in contact with water. And actually, it was a 10% increase of the moisture content. So originally it was 10%, um, 10% wet of in the glulam beam, but then maybe something happened where it rained or um, there was a storm and it actually increased the moisture content. What ended up happening was that the beam increased by a couple of fraction of an inch um, in size, so in height and also in width. These are small fractions. You might think, oh, it's not a big deal. It's not like it's very small. You can't see it with a naked eye. Maybe you have to zoom in a bit, come closer to see like the changes. But this is still an issue, especially when it comes to steel to timber, because since the wood expanded, um, if you have a steel to timber connection right here, what ends up happening is that now you're applying more force. What ends up happening is that wood applies more force to the wood that was designed for. So say for example, you designed the screw, like you calculated, you wrote on a sheet of paper that you want this screw to handle 100 pounds of shear force. I'm like, okay, 100 pounds, that's designed for it. Maybe apply some safety factor to it, like just to be on the safer side. So it's 100. Once the wood gets wet and it expands, it it adds maybe let's say it adds 10% of what you designed for. So instead of the screw dealing with 100 pounds force, now it's dealing 110-pound force. So you might be a little safe because you apply a safety factor to it, say, okay, and in actuality, it can resist 120 pounds of force. So you're okay. Like this is what you designed it for. Um, you cut it short, but you're still on the safer side. Uh, but what the bigger issue here is that not in the shear direction and the left to right direction, but it's the actual resistance where you have to pay attention to because um, wood likes to expand, and when the wood is wet, it expands a lot, and it creates a lot of force because of that, and because it wants to expand up, it will push anything out of its way to do that. So if you have a screw here installed right here, like yes, if you have a screw installed into a beam, and what ends up happening is that when it gets wet, it wants to expand upwards. When it expands in many directions. The screw, however, it says no. My purpose is to push, pull these things together, pull the metal, the timber connection together. Now, because of the expansion, it creates a lot of force. It creates about 90% of tension force. So, say for example, you designed the screw to deal with 100 pounds of tension. Now it's dealing with 190 pound force of tension. You designed the screw to handle 120, now it's 190. Now you're in a super danger zone. And now this becomes an issue with the screw either snapping because of the tension force or the screw dealing with a big corrosion rating because now you have the coating, the coating of the screw um, being weakened by the water. And because of that, it creates another bigger issue, another thing to talk about. So you have to, so as I said before, keep the wood dry, especially metal to timber connection. You can do it, and it also becomes an issue for wood to wood connection. It the tension increases by 20%. Um, However, when it comes to metal to timber, this becomes a very big issue, as you can see how much percentage it increased in tension. So yeah, and just to give you guys an understanding, like the research we've done on the different type of wood, and also not different type of wood, different steel plates, and what happens with the screw. So you can see here we use a thin plate screw, we use a thicker plate screw, and then we also use a thicker plate screw with one of our soundproofing product called the xylophone. Um, this is a rubber, like kind of like a rubber band, but very thick rubber. It actually very useful for like maybe like on the walls where you want to avoid sound from coming from the bottom floor or the top floor to seep in the current floor you're in. This actually protects you from what is considered as sound blanking, where sound can get through these very corners right here of your buildings. So we did testing of it. We see like, okay, we we applied the screws here, the plates here with the plated screw, and then we wet it uh to right here. Yeah, we wet it up to about increase it by about 20%, 30%, yeah. So it became very super wet, whereas like the moisture content of the wood is 40%. And you can see here after 6 weeks, you can see that the wood is very creates a lot of force that it can actually bend the plate right here. So a thin plate, not as much. You can see it would bend it by a lot, and then expand it by a lot. A thick plate, you can see here, it doesn't deform as much. Um, yeah, actually stayed about the same. Um, same resistant. It could be with the how heavy the plate is, and also with the screw being used as well. And then you can see right here the same with the washer, with the xylem foam washer application here. You can see here the size stayed the same. But the issue here is that the tension it created on the screw. The screw can be dealing with a lot more tension than than it was designed for, than it was calculated for. So yeah, the wood stayed the same. The steel plate is protected, it's not bended, it is not bent or deformed. However, the screw might could be dealing with a lot more tension than it was calculated for. So that's something to keep in mind. So we talked about a lot about water. Now let's talk about something that like people like to talk a lot about mass timber, and that's fire. Um, we always hear the argument that, oh, like, I use wood to barbecue. I don't use steel beams to cook up my grill. I said, why should I use timber? Why should I use glulam beams? I mean, yeah, sure, that thanks for the obvious conclusion, but um actually wood can be a good source of can actually resist fire just like steel. The only thing you have to consider is like how the duration of it, like what's happening to the material. So here we did like a analysis of like what happens with timber and steel if exposed to fire. You can see here that about after 10 minutes, not even 10 minutes, even before 10 minutes, like about right here in the mid-range at 5 minutes, you can see here that the steel starts to lose its strength. And the reason for that is because if you ever heated up some sort of spoon or some sort of metal, some sort of plate or something, or have you ever seen those videos where like people are making the sword crafts? You can see here they use like kind of looks like lava in a way, where they heat up the sword for so much that if they just hammer it, it actually takes shape. It's actually to be able to bend, it's able to change the dimension and change strength. So that's what's happening right here. The steel is actually losing its strength and becoming more ductile. It's becoming more bendable. And see over time, the steel after 20 minutes, the steel has lost 80% of its strength. Obviously, this steel was exposed. It wasn't protected. It didn't have an extra layer of coating like a fire layer coating. If it did, maybe the strength would have stayed consistent. But if we look at the wood here, you can see here that wood, even after 10 minutes, the strength stayed the same, about the same, about maybe dropped to 90%. After 20 minutes, it's dropped to 75%. It dropped to, sorry, 30%. And then later on, after maybe like about 40 minutes, you can start now reach the same level of the steel strength when it was burned for 20 minutes. So you can see here the how much resistant um is losing um, as it stays in fire. And the reason for that is because timber creates this char layer around it. If you ever guys burned wood, you can see that it creates like this black rock um, around it. And if you were to crack it or maybe like take it out of the fire and like let it cool it down, and then maybe start seeing what it is, you can see it creates this like very rock chalk like layer around it. Um, and this actually is char, and actually acts as like a fire resistant, as a fire protection for the wood. And it's what the wood what the wood's supposed to do. It's supposed to create a layer to protect itself. And so this is another reason why I'm saying that wood is still alive, even if you cut it down, because it's actually trying to protect itself from the fire, from going inside to the wood. Once the wood is inside the Once the fire is inside the wood, then the beam becomes a danger, loses structurability. There's no more argument of like, oh, the wood can handle it, for up to 40 minutes. Like, no, it's gone. It's You have to replace the wood. So, um, so if you make if you connect the dots here, um, you want to protect the wood from going inside, so it creates a char layer. But then we have these screws and these bolts inside the wood, so you just penetrated the wood, so now leaving the wood exposed. And if you ever, if remember from your science class, steel is very conductible. If you were to like put a spoon next to a stove, it heats up much faster. So um, what ends up happening is that the heat carries on towards the wood. And this is talking about fire. It's been going on for like 40 minutes. The temperature probably increased by a lot. You can see here the fire on the temperature of the screw at 300, about 400 degrees Fahrenheit, where the screw heats up so much that it's able to burn through the wood. And this is an issue because uh, the wood creates this char layer so that no fire can go inside. But now it's penetrated. Now there's a hole in the wood, and the fire is able to go inside, and it actually weakens the wood a lot more. So how do you go about it? Like what do you do instead to deal with this type of to avoid this in case of a fire? Um, the most common thing, obviously, is going more inside, penetrate it into the wood, like make a deeper penetration. Um, so we did like four testing of it. Like we did what the screw was on top of the wood. And then it was about zero point 0.4 inches, and then about an inch inside the wood. And then what happened, we covered up with like a wood cap right here on top, right here. And you can see here that the screw left on top, flush with the surface of the wood, it actually damaged the wood a lot more versus, for example, the screw with the wood cap on top. Um, it actually protected the wood from the heat and the fire. So there's something to keep in mind to determine the how the fire resistant as well. What kind of fire rating you want? You want a 1 hour fire rating, a 2 hour fire rating, and the NDS we provide it provides guidance like okay like what would be what would be your the effective beam and the effective beam width and height of the glue beam you're working with. So that can actually that can actually push it. Like for example, you have a beam width that's about 12 inches, but you want a 1 hour fire rating. So you're not working with 12 inches. You're probably going to be working with 8 or 9 inches instead. So that's something to keep in mind. And if you're using screws, we would recommend just going more inside to the wood, keep it away from the fire and protect it as well. Um, so it'll also be provide a lot of fire products as well. Sometimes another solution could be just putting tape above it. One of those tapes that we've done testing on is our speedy tape. This tape right here at the bottom, right here. We actually did a lot of fire testing on it. With RISE, it's a research institute in Sweden. We actually published it online, so you can, if you want to read more about it, you can go to our website and have a look. But yeah, so. Fire and water, obviously they're all big issues here. But there's always a way to prevent it. Um, and with wood construction, if you're a builder, like with wood, you have to be very precise. You have to consider even the smallest milling of the beam, like how much you're protecting it, how much you want to keep it hidden. Like for example, like right here, uh, uh, this person used dowels and they put there's two ways of protecting the dowels. Like you can put wood caps here, or you can, apply this plywood on here. I mean, you can see which one I like. I like this one more. You can see which one looks cleaner, which one looks kind of messy. So there's always a solution to like prevent keeping fire from going inside and water from going inside. So something to keep in mind. Um, and yeah, this just gives you more information about fire ratings and stuff. Yeah. Yeah. So um so you might think like, okay, thank you for telling me all about like what screws to choose, how to protect the wood, how to protect it from fire. Now I want to design a connection that can handle a lot of weight, but I don't want to use very complicated things. I want to use something very simple, like maybe screws. And we can say that's possible. You can use screws instead to handle big loads. So here we give you guys two scenarios. We gave you like partially threaded screws, and then we also give you fully threaded screws. Partially threaded screws is like usually right here with like a very small threaded portion and a very like shank area. You can see here the difference between the two, where partial threaded is very ductile. It's able to, you can see it creates this rope effect right here, or like it's able to create like a very ductile connection. And then this right here, we have a very stiff connection that because of the fully threaded screw, is able to keep things together. Not only that, you can see that it's crossed like an X. And when you cross screws, it actually creates a lot more resistance. So, for example, right here, if you look at the example right here at above we did, you can see here that um, we did a testing, like going shear, so like one would go on one side, the other going on the other side. You can see here, four screw was able to handle about uh, a kip or 980 pounds force. But then you look on the other side, solution B, where maybe you don't use a lot of screws. You're only limited to maybe one or two screws. If you use one fully threaded screw, one screw itself can get you 800 pounds. So maybe you design it for 1,000 pounds. Okay, maybe you can go for a longer screw, or maybe two screws, smaller, because then you're not like dealing with all these, like maybe there's not enough space, but there's space for like maybe two small ones. That can give you the resistance you need using less amount of screws. So cross screws are the most simplest, in this case, the most simplest way to get you the high resistance you need um, for shear. And since these screws are certified, our screws are certified according to the ICC. Um, Cross screws can give you the ICC connection you're looking for. So uh, with that, you're able to two screws going across. One like on this picture right here, one going to the beam, one is going to the main beam. You can see here that is able to give you enough resistance. And if you'd like to learn more about the what resistance that might be, you can check out our website for the catalog for the technical data sheet. So yeah. And then lastly, this just tells you like the what screw to use for what. I mentioned that plate headed screws are good for metal to timber, but you can also use the condensate screws as well, if you want. However, you have to make sure the plate itself is able to are kind of sunk holes, so it's able to sit perfectly. Or you can also use a washer instead. The washer is very helpful, like for kind of some screws, because you don't have to make the hole in the plate. You can just use the washers instead. So yeah. Mm, nope. Yeah. So yeah, just more on this like understanding like how to go about it, how to install metal to timber, uh, what should the screw be. We also have outdoor screws. So this is like our stainless steel or our C5 Evo coating. You can see they're different heads. The KKT, this is our very good screws for like for decking. They also have different color heads as well, so you can use different type of color screws for decking, so you don't have them be very noticeable. They can blend in and camouflage with the wood. Yeah, and just more give you an idea of what it is. But just to wrap things up with you guys, the practical side, we also did some testing as well, like about the distance as from each other. So. Um, as I said before, wood construction has to be very precise. So you have to consider everything, even the distance between the screws. Because if you don't, what ends up happening, for example, right here, you can see here that they put these two screws together, but they're way too close than it was meant to be. You can see crack starts forming, crack started forming right here. And then this person put the screw way to the edge of the wood, and you look what happened. Now you damaged the whole wood. Now you have to replace not just the screw, but the whole piece as well. So that's very expensive damage. So you have to make sure and consider like, okay, uh, how do I want to install the screw? Like, do I want it to install it like just like that from like easy, or do I want to pre-drill? Pre-drilling, we provide guidance here as well. Like you drill a hole first, like a smaller hole than the screw, and then you insert the screw inside. You can see here the damage it does without pre-drill, and then the damage it does with a pre-drill hole. You can see it's minimum because now you're providing guidance for screws to go inside. Um, Usually a lot of people are very specialized. They're like the experts. So they know how to how to insert the screw correctly. However, if you want to be very precise, be 100% sure that no cracks will form, we recommend the pre-drill hole. And with pre-drill holes, you're able to reduce the distance between the screws because the reason for that is because now you're reducing the chance of this happening like splits right here. Uh, it might be very small, like yeah, like you can notice it, but this is very important because the last thing you want is damaging the wood. The wood pieces are one of the most expensive things. So, any if you see the small cracks, okay, like it's not a big deal. But then you see them everywhere, and okay, now you have a bigger issue. So, they want to keep them close. Go with pre-drilling. This reduces the chance of the splitting happening. So. And we also did more testing as well, like to see what type of drill machine to use. We always recommend regular the regular like screw guns, screwdriver, like machine just used for screws, wood screws, not screws for not bolts into steel plates or steel bolts or steel beams. Because what ends up happening, like this, if you have an impact driver, for example, this creates a lot more torque than you need it to be. And if you ever held a torque, an impact driver, you can see how strong that is. And wood screws are not as strong as like bolts. There's only a certain amount they can handle. So right here, for example, like um, we gave you some guidance here as well, like what the torque rating needs to be on the screwdriver. Um, so you can use a screwdriver, screw it in. You want to be very precise, very safe. Maybe you have a lot more time, not in a rush. What you can do is screw in the screw just as about to touch the washer or the steel plate. And then finish it off with a torque wrench right here, just to keep it tight, just to keep it precise. Um, we recommend not inserting like once you feel the screw touch the plate and then you screw it in just to keep it more tight. Just to be sure. Don't do that. You're actually causing more damage to the screw. So because you're tightening it more than it needs to be. So once you feel like maybe like if you don't want to use a torque wrench, once you feel the little kick, that's it. It's done. Like you don't need to keep going. Um, we also have other things as well to provide you some guidance. Maybe you could use a torque limiter just to help you with that. Like you don't have to like guess, okay, I felt kick, or maybe I didn't feel kick. Let me tighten it even more. Like there's a way to go about it. So yeah. Um, yeah, and then there's more information about the about our drill machines and also like about the membranes as well. But other than that, what I like to conclude is like, one, protect the wood, protect your connections, make sure you have a water mitigation plan. Two, make sure you're choosing the right screw for the right project. Am I going to be close to the water? Am I going to be away from the water? Do I need stainless steel or can I just a regular zinc plated screw? Can that handle the job? And then lastly is what tools am I using? Am I using an impact driver or am I using a regular screwdriver? Um, ca- will this be enough to insert the screws or would this be too much that it might damage or break the screw? So something to keep in mind. So yeah. But other than that, I think that's all I have for today. Thank you guys for coming. And if you have any questions, just let me know.
Looks like right now in the Q&A section, I don't see any questions currently, but I will mention if anybody does have any questions after we conclude the presentation and close it for the day, you can send an email to eng.na@rothoblaas.com. I also too want to remind you that we do have more webinars coming up this month. Um, Next week, at the same time, we're covering some case studies on the pillar, spider, and TC fusion building solutions that we have. The following week on the 17th, we have a special guest presentation on digital design tools for modern timber construction with CLT Toolbox. That presentation is actually going to be at 2 p.m. Eastern. And then the last presentation of the month is on the 24th at 11 a.m. Eastern Time, investigating timber concrete composite floor systems in mass timber with a guest speaker from a university here in the United States. So, um, as always, we thank you for joining and we look forward to seeing you again in the future.